Hello everyone, Nicola here once again from the Bonita Soft marketing team. I'd like to welcome everybody to the last day of Bonita Days 2018. So up until now, we've covered topics such as digital transformation, the cloud, and we've discussed our technology partnership with DocuSign. Fear not if you've missed any of these webinars, they will all be posted shortly on our YouTube channel. We invite you to actively take part by submitting any questions that you might have. So in the chat or questions area, it's located at the bottom of your GoToWebinar dashboard. And our webinar hosts will try to answer as many questions as possible. Today's webinar title is Process-Based Applications Are an Optimal Support for Artificial Intelligence. Your host is Bonita Soft Research and Development Manager, Mr. Nicolas Chabanol. So without further ado, I'd like to welcome Mr. Nicolas, and I hope you all enjoy the last day of Bonita Days 2018. Thank you.
Thank you, Nicolas, for the introduction. So welcome everybody. So again, my name is Nicolas Chabanol, and I'm an R&D manager at Bonita Soft. I've been working for Bonita Soft for almost 9 years now. So yeah, the subject of this presentation is process-based application as optimal support for AI, so artificial intelligence. When you look on the internet for artificial intelligence, you can find a lot of resources. And mainly artificial intelligence is not the only keyword you will find in those documents. You may find predictive learning or data analytics, or data mining, or machine learning, or any big data keyword as well. At first, it might be very confusing and seem very complex to get an introduction to artificial intelligence. What I intend to do with this presentation is to give everyone a very basic understanding of all the concepts and see that even though what you can do with all these techniques is very powerful and very maybe tricky sometimes, there are some basic concepts that everyone can understand. So this is the mission for this presentation, give you this understanding. First of all, I would say that the most generic term you can find on the internet that gather all these keywords might be data science. And this is what we will do today, a bit of data science. So let's start with a game. Maybe this is the easiest way to get a hint of what data science is by playing a bit. So I suggest to play to the Price is Right game. Maybe someone knows this game already. And let's say we want to make a prediction to find the price of a meteor. So let's say John wants to buy a moon meteor 4 grams for Christmas, for a gift maybe. And the game here is, can you predict the price John will pay for this meteor? So unless there are some very passionate people who knows what is the price of moon meteor of 4 grams, I don't expect the majority of you being able to make this prediction. At least not right away, but in a few minutes, I guess most of you will be able to do that. So if I tell you that this prediction is just a matter of resolving a mathematical equation, and if I give you these hints, let's say that the price depends on the person who wants to buy the object. Here the object is a moon meteor. We know that the size of the meteor is 4 grams, and we know that John wants to buy it in December. These are the most valuable information we have, and normally with all this information we should be able to guess the price, to make the prediction. But maybe it's not enough information yet for you to solve the equation. So let's say I give you more information. And what about now? If I give you the sales report regarding Meteor, can you guys try to make a prediction on how much John will pay for this moon meteor of 4 grams? So we give you just maybe a minute or two just to look at the data and try to figure out and give me some hint what the price will be for this meteor. So I'm really expecting you guys to try to solve this equation. So if someone wants to make a guess, he can provide some answer to the chat in the webinar. Okay, so someone is saying $890. Okay, can you tell me why you think this is the price of this meteor? Okay, so you look at the price of October and see that the weight is 4 grams, and you say, okay, because my meteor is 4 grams as well, the price will be the same. Okay, that's kind of a prediction, but I don't think it will be the right price, just because what has been sold in October is not a moon meteor, but a Martian meteor. And I guess the price is not the same, because Martian meteor might be less available on Earth than moon meteor, so I expect the price to be less than your prediction. Any other predictions from you guys? Okay, so I see another answer. Someone is saying, okay, around 340. So yes, for this one I can guess the reason. Yes, if you look at September, you see that 2 gram moon meteor has been sold for $170. So for 4 grams, it's just twice the same size, so the price might be twice. Okay, so I can understand this reasoning. So yes, I agree with this prediction, but mine would be less than 340, it would be 320. Why? Just because just in August the price was for 1 gram $75. So it's not an exact relationship between the weight and the price. It's maybe depending on the buyer. Maybe you can ask for some discount or stuff like that. So the price is not exactly the weight multiplied by 75. So yes, $320 seems a reasonable prediction based on the available data we have. So what did just happen here? Everyone of you did some mental scheme based on data, trying to figure out some relationship between the information we have and figure out how to compute the missing information, which is the price of the moon meteor. And yeah, you just notify some patterns in the data, and based on these patterns, made some extrapolation of the value you're looking for, and you make a prediction. So that's good. So actually what you just did is complete a data science project. Look at the data you have, find some pattern, some rules, some valuable information, and then extrapolate information, some knowledge from the data, and based on this knowledge you can make some predictions. So this is data science. That was very easy, right? But yeah, of course, building a real data science project is a bit more complex than what we just did. But basically the concept and the way of doing it is exactly what we did. Build a mental scheme based on data, get knowledge from the data, and then try to figure out the missing parts of the information you're looking for. So basically when you have a data science project to build and to operate, you always need to start from the goal of your project. And it's always the same thing. Find the answer to a specific question. Okay, so it's useless to start a project if you don't know what is the answer you're looking for, what is your goal. Once you have this specific question you want to answer, then you can start. So let's say for us who are working on the BPM field, a valid question could be, when will my process complete? When will my process instance terminate? Okay, this is something very variable for us when we build BPM-based applications, just because all the users want to know when the process will end, just because it means that the ultimate business goal has been achieved. So this is the use case we would like to implement, and I will invite you to go through the projects to build an application that will specifically answer to this question. So when you have a data science project, basically we can say that there are 4 high-level steps you need to go through to enter your goal, to achieve your goal. So we already defined the goal. When will my process complete? Then, based on that, we need to know the data we can leverage. Based on the data, we might need to prepare it, meaning remove some data that are not useful, or maybe some you need to transform some piece of data to make it usable, or just stuff like that. Once you have all the data in the right shape for you to use it, then you need to build a model. What we call the model is just what we did with the moon meteor, is to have a scheme that allows you to find patterns in the data that you can leverage to gain knowledge, and then based on this knowledge you can make a prediction. So this scheme we had previously, the mental scheme, we just are going to build one with a computer and identify some patterns, and those patterns are called model. And then we will use this model to make predictions. Once you have this model available, then you might need to tune it, okay, to just make some piece of configuration to make your model more efficient. So these are the basic high-level steps when you go through a data science project. Of course, all these 4 high-level steps are subdivided in more specific concrete phases that you can see on the right-hand side of the slide. I will not go through each of them because it would be too much, so we will just focus on the 4 high-level steps just to get an understanding of what the project is and how it works. So again, our goal is to answer a specific question, which is related to case execution, process instance execution. And the question is, when will it complete? So we need data information to process, okay? So what can we use? Because we are looking at web BPM-based applications, what we have available is all the data related to process execution itself. So let's say, for instance, you have this red case execution going through all these steps. What Bonita BPM does is store into its database all the information related to when something happened in the process and who does all the actions and in which order. So basically what you get in database is what you can see in the table here, is all the timestamped information of what happened in the case. So I usually refer to process execution to case. So case, process instance, or process execution is the same for me. So I will use any of these 3 terms for the same thing. Okay, so don't get confused. Case, process instance, or process execution is the same for me. What we can see for this red case is that the duration was about 2 hours and 30 minutes. And this is one specific execution, but of course, a second instance of the same process can go in different paths. Let's say for the green case, what you can see is that for the same process definition, modelized here in BPMN, the duration is far less. It's only about 20 minutes, just because it goes through another path which is shorter. In the example we are seeing on the screen right now, it's just kind of purchase process where the customer is selecting an article, and based on the type of the article, the packaging can be automated by machine, then it goes very fast, or some operator has to package manually the article, and then because it's manual, maybe there is another person in the team that need to verify, double check the packaging to make sure the packaging is perfect before shipping the package to the customer. That's why the manual packaging plus manual verification is far longer than automated packaging, of course. So here what you can see is that depending on the path in your process, the execution time might be very different. And what also you need to understand here is that all this information regarding the path and the execution time is already available in Bonita database. And that's a very good thing because we have a lot of information available to do data science with. So that's good news, right? Now that we have the information, okay, of course what I presented here is just simplified version of the data we have in database, but it's good enough for the understanding. Now that we have the data, we need to choose a model. So again, the model is the look for patterns in the data that you can leverage to make some prediction. If you look on the internet and to search for all the models available that you can use for data science, there are basically two big families of models. First one is regression. So regression, you can find some definition, let's say from Wikipedia if you want. That looks like this. Regression is when you want to find a correlation between a numeric variable and other variables available. For instance, what is the price of a meteor? Price is a numeric variable, okay, it's digits. And you want to guess the price of the meteor based on other variables. So the variables we had previously was the time, so it was in December. You have the size of the meteor, which is 4 grams. Okay. There are multiple kind of regressions. So you can find linear regression, multiple linear regression, polynomial regression, and so on. So all of those techniques aims at finding a numeric variable based on other data you have. Okay. And there is another family, big family of model available, which is named classification. Classification aims at answering other type of questions, such as what animal is on the picture, a dog or a cat. This is a typical example you can see on the internet, and maybe most of you, if you have looked at videos or read about data science, this is usually the kind of example you can find on the internet. And again, the classification is aiming at associating an observation to a predefined class. So in this example, a dog is a class, cat is another class. They are predefined, meaning that the computer knows only 2 different classes, dog and cat. And then when you present a new picture, the system has to answer either dog or cat. It cannot answer anything else. It only knows the 2 classes you have predefined in the system, dog and cat. Okay. Let's take some more visual example. Maybe it can help for the understanding. But before that, just as a reminder, our use case is to compute the duration of a case when it will end. So it's more a regression kind of model than a classification kind of model we want to build. If we take a visual example, we can see that, okay, if I have a system that is configured with a classification model, and if you present the picture of a dog, it might answer dog. If you present the picture of the cat, it might answer cat. If you present a picture of another animal, which obviously is not neither a dog nor a cat, the system has to answer dog or cat. Maybe in this case, it might answer cat, because maybe this animal is more likely to be confused with a cat than with a dog. What is important to understand here is that the system may be wrong. Even if you have a good system, it might not find the answer 100% of the time. If we go for the regression, it's usually, if I take here the most simple example, this might be the price of the meteor based on the size, okay, which is the most simple regression. Then, depending on the size, let's say 4 grams or 10 grams or whatever, you will get the price. It's usually something like the size multiplied by the unit price, and then you will get the prediction. If you look at the image, the blue line gives you what the prediction will be depending on the size of the meteor. Okay, but the red points are the actual values. And what you can see is that not all the red points are on the blue line, which means that there is some error. When you make a prediction, you are not 100% precise. Okay, I think it's obvious to state this, but of course, if someone were able to predict the future or predict the unknown with 100% accuracy, then maybe I will be a billionaire using bitcoins, because I would use it to predict the price and if I need to buy or sell bitcoins. That being said, it's true that when you build a system, you try to make it the more precise you can, because depending on when you want to use it, if it is for healthcare or if it is for nuclear, I don't know, programs or stuff like that, you might need some 98% prediction fiability. Otherwise, you are taking too much risk. But if you are just looking for, I don't know, the price of the plane ticket, maybe 80% accuracy is enough. Okay, so depending on the use case, the accuracy you are looking for is not always the same, and for sure it will never be 100%. Or at least not yet, we are not able to build such systems. Maybe in the future, who knows. Unfortunately, if you carry on looking on the internet, you will find that many researchers spend time on trying to solve and to achieve the same goal we would like to implement here. That is identifying and predicting when a process will complete. And unfortunately, classic data mining techniques such as regression and classifications cannot work on processes because processes express a behavior which is far too complex. You have loops inside a process, you have some decisions, you have some human involved, and you have some relationship between tasks that cannot easily be interpreted just looking at the data the traditional way. So what those researchers try to do is implement a mixed approach where classification and regression could be used hand by hand in order to identify trends and patterns in process execution to predict some characteristics. So the questions they aimed at solving was, what will be the duration of my case? Which path will follow my case or process instance? Who will be involved in my case? And they call this mixed approach process mining. So obviously process mining will be the technique we will try to implement to achieve our goal and predict the case duration. If you look on the internet again for process mining, you will find a lot of articles, and the definition is something like that. Process mining is a set of techniques to analyze event logs of your process execution. There are specialized algorithms to find trends and patterns inside this data, and the goal is to better understand process behavior and performance at runtime. And among the use cases, they talk about process discovery, conformance checking, and something called extension. Process discovery is when you don't really know what is your process and you want to find it out based on data. In our case, we already know the process because it has been implemented on top of Bonita. So the process has been defined and automated, so we know it already. So we don't need process discovery at this stage. Conformance checking is when you want to use those techniques to make sure that the execution of the process is compliant with its specification. Again, inside Bonita, we don't really need that because when you design a process and ask Bonita to execute it, there is no way the process will not behave as you designed it. Okay, the execution will be following the BPM and description. So again, we don't really need conformance checking at this point. And then there is the extension. And extension is the technique where you use your event logs of your processes and you extend this information with some key performance indicators. So it looks like that. You translate the BPM data into a state transition system, and then you enhance it with performance information. And then after that, you can do some classification, then regression on top of those information, and then you are able to make some predictions and predict some characteristic of your process execution. If you look on the right-hand side of the screen now, what you have is a state transition system where all the circles represent a state of your process. So the very first state is the one with the curly brackets, okay, and this state is nothing happened yet to my process, okay, it's the empty state. Then you can see transition with the A on top of it, and then you go to the circle with the curly bracket and the A inside. So this is transition when the A activity has been executed, then you are in the state A has been executed, okay. Then you see there are two paths. First one goes to AD, which means that the A step, then the D step have been executed in my case. And the second path is the A-B state, which means the A activity and then the B activity have been executed. Okay. And for each state of this diagram, there are also indicators of the execution time. You have the average remaining time in my process, which means how long this process instance will last until the completion of the case. You have the minimum, which is in the past, for all the instances already executed, what is the minimum remaining time we observed from this state to the completion state of the case. And maximum is amongst all the information we have observed so far, what is the maximum remaining time we have observed from this current state to the completion of the process. Okay, so when you have this model, okay, the system has learned all this information based on all the archive from the database. Then if a new process instance starts, okay, and then you can use this model to say, okay, my current case is in state A, B. Okay, can you predict what will be the completion state of my process instance of my current case? Then we can leverage the average, the standard deviation, the minimum and the maximum, then do some classification and regression algorithm, and then make a prediction and say that if your current case in this state AB, the average is 75 minutes before completion. So maybe answering that 75 minutes before completion is a good prediction. Okay. Okay. So this is the idea of the process mining. Learn from the archive, build this model, and then when a new instance of process is triggered in your system, try to use this model, do some classification and then regression to figure out the execution time of your process. Here, all the time we have for the average, min and max are the information we have registered for the green case and the red case we have seen before in the presentation. Okay. And of course, the more executions you can learn from and more precise your model is. 2 executions is not enough. Okay, this was just for the understanding of the concept. So that's good because now that we have this model and we are able to learn from the data, we are in a state where we can make predictions. So basically that's it. We have implemented a data science project using process mining. What is very nice with the process mining is that, as you have seen, there is no need for extra information than process execution log. to start working and making prediction. So that's very good news for us because it allows us to implement this use case without all the complexity to integrating business data. It's somehow quite easy to understand and interpret, and at least I guess I've been able to explain it clearly enough so that you can understand the way it works. And the other advantage, which is very nice, is that yes, we can predict the case execution, and on top of that, we can use this mechanism not only to predict, but to suggest some changes. So this will allow us to integrate more use cases in the future in our new module that does data science. The other use cases we might implement in the future is what's the chance to go through a specific task. Let's say your process is dealing with healthcare, and one of the tasks is send the patient to the hospital. If you can predict in advance that this task it's highly possible that this task happens, then you can anticipate a bit and prepare everything so that the patient can be sent to the hospital in the best conditions. Or even avoid to send the patient to the hospital because you can, let's say, provide him with the right medicine. Other use cases, chance to have a person involved in the case, which is good when you want to anticipate a bit who in your team will be involved in a specific case, and maybe we can identify bottlenecks in teams because it's always the same person who does specific tasks. Then next week maybe this person will be overwhelmed by the work, whereas someone else in the team has nothing to do. So it might be very interesting for routing activities to people in the team. And another use case could be detect error before the error arrives, which is good for all the DevOps guys, for instance. And of course, we can list more use cases and more use cases using those techniques. So that's good because it means that we have a lot of things we can provide to our customers by implementing such projects in Bonita platform. So if we go back to the four main steps I talked about earlier. So first of all, we identified the use case, which is when will my case end. Then we get the data. So all this data are available inside Bonita BPM archives, the database. So that's good. It means that we can implement a data science project using those information. And okay, but those information need to be extracted to somewhere else to be interpreted to build a model. So the somewhere else is called ICE, which is Intelligent Continuous Improvement Module. So I will just give you a picture of what is this new module I'm talking about. And based on this new module, we will be able to do process mining techniques to build a model. And then on top of this model, we can do some cross-validation to tune it a bit and make good predictions on when my case will end. So let's have a look to the implementation of this project I'm talking about. This is the main architecture. So on the left-hand side, you have Bonita, or Bonita BPM, which was the name of the previous version of the platform. And inside Bonita, you have all the server and the engine for the execution of the processes, and more especially, you have the database. Inside this database, we have all the log information of process execution. So the same way I showed you the green case and red case, and every time an activity is executed, we log in database who did the action and when and the time spent in between activities. So the information are periodically extracted from Bonita database through the new Intelligent Continuous Improvement add-on to the platform. And those information are extracted and a bit transformed and stored in a new storage area, which is Elasticsearch from a technical point of view. And this is from this Elasticsearch storage that we build a new module that is able to learn from the data and build a new model using all the process mining techniques and specific algorithm, and are able to make some predictions. We have exposed all these techniques through new APIs that can be leveraged from Bonita. And from the platform directly, we can have developers or operation managers using living applications from Bonita to get access to the predictions and interact with the system to better operate the processes, basically. So that's it. And of course, as usual, what is the strength of Bonita platform is the extensibility. So what we did is keep open the possibility to our customers to build their own applications on top of these new APIs and on top of this new add-on module to get access to the data and predictions and the model itself for process mining, so that they can build their own applications to better serve their final customers. So this is the main architecture of the new add-on that we have built as a result of this data science project we just discovered and goes through all together. Why is that? Why are we talking about data science today, and why did I explain to you data science and how we went through this project? It's just because here at Bonita Soft, we want to go through what we call intelligent continuous improvement of process-based apps and help you guys to better operate your processes by having a better understanding on how they are executed and where the time is spent and who is involved in the process and how, and trying to help you make some decisions on how to operate them better. So how this could work. We want to provide you guys with some prediction-based application on top of your own business goal. So which means that you will have to define your goals in the system, and then we will make prediction to say, yes, your goal will be achieved, or not, the goal will not be achieved. And then based on this prediction, you can operate and change things and try to influence the system so that you achieve your goal, because ultimately this is what everyone wants. Besides the predictions, we want to make some recommendation. It's not because the prediction is not good that you cannot act and correct the system. Okay, so we want to make some recommendation, give you suggestions on how and what to change in order to achieve your goal, or at least reduce the delta between your goal and the prediction. A fair example here could be, okay, maybe currently the task is assigned to someone who is on holidays. So if you want the case to go faster, maybe you should reassign the task to someone else, someone who is currently available, so that he will be able to work on it right away, and then the case will go faster, obviously. So this is the kind of thing that the suggestion and prediction can do for you. Identify that, okay, maybe you missed that information, but the person is on holiday, so the reassigning to someone else will improve the execution time. There are two kind of actions that can be taken when the predictions are not good. Here we have named these two kind of actions, short loop and long loop. Short loop are all the actions you can do right away in order to influence the prediction. So again, reassign a task is short loop because you can do it right away, and then you can see the benefit on the achievement of your goal. Or you can, I don't know, change connector implementation because you see that the time is spent in connectors, and maybe it's because the connector is not implemented properly, then you are losing time. Or maybe you're using a form, and the form is far too complex for the users to fill in, and you see that they spend a long time filling it. So maybe simplifying the user interface might help the execution time. So this is the short loop because this is something you can do very easily in a very short time. And you can influence cases that are currently running and improving them right away. Long loop is more when there is a big change to make on your application, so either at the process level or at the user interface level, but that needs time for redesign and rethinking of your project. So this is what we call the long loop. So here it will be more something like, okay, maybe if you change your process definition and move those steps that are in sequence to parallel execution, obviously you will save time because they can be done in parallel. These are more impact on your process and application, so this is not something you can do right away. You need to take time to think about it. So this is what we call long loop. Anyway, when you have a prediction, you have a suggestion, you can take an action, and when you have taken this action, you can measure the impact of your action and see the impact of the prediction and the achievement of your goal. Okay, so this is continuous improvement because this is not something you will do only once and it's done forever. Obviously, the context will evolve, your business will evolve, your organization will evolve. So this is something that everyone will have to do regularly, and maybe I don't know if it's daily basis or weekly basis or monthly basis, but anyway, this is something that to be done very regularly, and this is the cycle you will be able to do with the new model, the new add-on. Just to give you some preview of this new add-on that we are implementing. So this system will anticipate, will allow the operator to anticipate if a deadline will not be met. Okay, and then the operator can take actions in order to fix this and make sure that all the deadlines are met. So this is the Respect SLA application. So these are actual screenshots of the new module we are currently implementing, again, which is called Intelligent Continuous Improvement so far. So on the right-hand side, you can see that this is an application that runs very nicely on your mobile. So which means that someone who wants to look at the operations and make sure everything is on track can just connect through the mobile and check graphically based on the data if everything is okay or not, and if not, can take actions. And the other screens are for the configurations. So yeah, there are several screens, of course, and depending on if you are in the operations or configuration aspect, then you have to connect to the right interface and work with it. Okay, so I think that's it for me. I would be glad to answer to all your questions if you have. So either regarding data science in general, or more specifically how in Bonita Soft we intend to deliver this new add-on module to you guys to improve your operations and make some predictions to help you take valuable decisions. So yeah, so I will take some questions. Let me look at the chat for that. Okay, so I have some questions. Oh, sorry about that. So I have a question in French, so that's funny. So is the extension supposed to be installed on independent server, or everything can be installed on the same server? Actually, there is no constraints regarding the deployment of the new add-on. It can be installed on the same server as Bonita or on a second server. It will just depend on your infrastructure and the size of your server. So if you have enough space, especially on disk space, because we will extract some data and store them in Elasticsearch, if you have enough disk space, you can put everything on the same server. Just to mention it, the data we extract to Elasticsearch are not very huge, so you don't need a terabyte to store everything, just some megabytes are enough. So yeah, then after that it depends on your IT strategy. Okay, another question. So this new add-on is still under development, but it will be delivered soon. So we already have some customers and working with us and having access to it as a preview, so that we can get feedback from them and improve the new module. So either on the user interface aspect or on the model aspect to be more effective in predictions. So yeah, and the availability of this add-on is for the next version of Bonita, so which is around June 2018. So I hope it answers the questions when this add-on will be available to you guys. Okay, so I think that was the last questions, and I'm not sure we have more time for answering other questions. So thank you very much, everyone, and I will let Nicolas maybe do the wrap-up. Thanks, guys. Bye.
Surely. Thank you, Nicolas, for a great presentation. Once again, I would like to invite everybody to register for our last webinar in this Bonita Day 2018 series. It's coming up shortly, in just about 10 minutes, so 10:30 a.m. Pacific time. The webinar is titled Trace and Authenticate Data on the Blockchain with Bonita and Stratum. Stratum is also one of our technology partners. And hosts of that webinar will be our in-house tech evangelist, Lionel Palacin, and also the tech evangelist from our partner company Stratum, Sebastian Couture. So I've added the links in the chat to register for this final webinar. I've also added a link that you can visit. It's a link to our contact form. If you have any questions or would like to discuss in more detail about any ongoing projects, future goals, or issues that you might have, so please feel free to reach out. Once again, I'd like to thank everybody for attending, and I hope you have a great rest of your day. Thank you.